Let us try another example here. So I have already the English arguments. If my computer crash, I'll lose all my photos. I haven't lose all my photos, hence my computer hasn't crashed. So by logic, I mean, if we use our own intuition, reading this statement, definitely we can tell that yes, this is valid, because the first statement say if the computer crash, then you will lose the photos. But the fact that I haven't lost all my photos, so we can say that the computer not yet crashed. But that one with intuition, how we are going to prove this? By propositional logic structures. Okay, so things that we need to do as before, we need to convert these arguments into propositional logic structures. Now let us highlight all the atomic propositions. The first one, we have my computer crash. Next one, we have I lose all my photos. Next one, the same scenario, I haven't lost all my photos. And next one also still the same scenario, my computer hasn't crashed. So there are two atomic proposition here. The first one is about computer crash or hasn't crashed, and another one is about photos, lost all my photos, or another one haven't lost all my photos. So let us put or initiate computer crash with A, computer hasn't crashed, this is the negative, so become not A. And the I'll lose all my photos become B, hasn't, oh sorry, I haven't, so the haven't one is the negative, it become not B. Okay, so if we put all in one now, the first one, if my computer crash, so this is an implies. Okay, if crash, then lose all the photos, so A implies B. This is the first statement or the first atomic propositions, and full stop, so means conjunction. I haven't lost all my photos, this is not B. It's up to you whether you would like to, because there is a conjunction here and negation here next to it, you can either you want to put bracket here or you don't want to put, it's okay. But my advice, you can just put the bracket. Okay, so the next statement, hence, so this is the final statement. So final statement, it is and implies to not A. So with logic, how are we going to prove that this is valid? Of course, we can make a use truth table. So now let us do the truth table for this one. Since I'm too lazy to draw the table, so I will just do the value here. So A will be true, true, false, false. B will be true, false, true, false. Then I have not B here, so meaning false, true, false, true. And then I have not A, the last one, it is false, false, true, true. Now let's do the logic operators here. The first one we have, let me use color, this one. Implies, A implies B. We already know for implies, only when it is TF then it is false. the rest will be true. So this one true. Then we have TF here, the second row, this is false, this is true, and this one true. So the next one that we need to do is the one with conjunction. Okay, I can highlight here. First one, get 3, this is 4. Now between 3 and 4 we should get 5 here. So the conjunction between 3 and 4, remember the rules of conjunction. The rules of conjunction says only when both are true then it is true. So if we look at the column 3 and column 4, the first row TF, so F, the second row FT, F, the third row TF, F, the next row TT, so this will be true. Okay, so the next one will be column 5 with column 6, and the final result will be column 7. So column 5 with column 6 is implies. Remember, implies only when it is TF it becomes false. So with this, what will be our result? First row FF, true. Second row FF, true. Third row FT, true. And the last row, the fourth one, TT, true. Now we get the final result is all true. Then if this is the case, we said that this is valid. There you go, that this arguments is valid by the proof of the truth table as we have in here. So this statement valid. So this is how we prove if an argument is valid or not. So we can make use the help of truth table in order we can make a proof of it. Okay.